Okay, so in this section, we're going to learn a pretty important application. Vectors are basically used a lot in science, right? Obviously, in math being the language of science, used in math. And basically, to just give you an introduction of why we need them, um, a lot of times what we have in mathematics is something that has just magnitude. Magnitude is the size of something. So, how much money do I owe you, or how long, is the table, or what area is a table? Those are all magnitudes or sizes. Heck, even speed, right? If I have an airplane and I told you that it's traveling at 500 miles per hour, right? This is a magnitude because I'm just basically telling you how fast or how big something is. And speed is missing a very important component because the airplane that's flying, right, we'd want to know which direction it's headed, right? And as soon as I have magnitude and direction, what we are now talking about, right, is velocity in terms of a science setting. But in what I'm trying to teach you guys right now, we now have a vector, right? So a vector, right, by definition, a vector, right, has both magnitude and direction. All right, so thinking of the airplane, things would be very different if I told you that it was traveling at 500 miles per hour at a bearing of 60 degrees. Right now, what I have is I both have how fast I'm going, speed, magnitude, and the direction. And so I can even draw a picture now, right? So when I draw this picture, right, we know that our bearing is 60 degrees from north. So there would be my 60 degrees, right? And I'm traveling at 500 miles per hour. And so now what we have is basically the essence of a vector. All right, and so this basically takes us, now that I've kind of introduced why we need that, let's go ahead and kind of get a little more detail, right? All vectors have a start point and a terminal point. If that sounds familiar to you, I hope it does, because that's how we kind of started our trig journey. So our vector for our airplane, right, it's got a start point and it's got an end point. At times we call the start point O and the end point P. And so notationally, the vector that I'm dealing with here, right, is OP, with O giving us the starting point, P giving us the ending point. And this little line segment that I have at the top basically tells us that we're talking about a vector quantity. If I just left OP by itself, right, it's pretty meaningless. But as soon as I put that little vector sign on top, I'm now talking about something that has some vector qualities. It's got a magnitude and it's got direction, all right? And the cool thing about vectors is that vectors are equivalent if they have the same magnitude and direction. So the vector that I drew here, if I was to draw one that has the same size and same direction down here, they're equivalent. Even if I moved it over here, right, that's equivalent. Or if I moved it here, that's equivalent, right? And so it doesn't really matter where I place the vector, as long as it has the same size or magnitude and the same direction, they are equivalent vectors for us. And so you now start getting a feel for what we call a vector field, right? Because we have this flow, if you would, with these vectors. Again, back to the idea that, in science and math, vectors play a huge role. Vector fields are things like your gravitational fields, your magnetic fields, the flow, the fluid flow through a pipe. I mean, you name it. So we've got basically our vectors, all right? And so what this allows us to do then is, since we have equivalent, what I can do is take one of these guys and I can orientate it on my X and my Y axis, right? And because I can do that, right, this vector that I have here is equivalent to any of the ones that I have over here, right? O is on the on the origin, and P is basically sitting there at the end point. And what we basically have, right, is an angle theta now that we have, right? And so we have my magnitude. As a matter of fact, we use these straight up and down lines to represent magnitude. So I have how long this vector is going, and I also have an angle that gives us the direction. So the theta gives us direction, and this crazy notation that I gave you just popped on you, right? Gives us how long we are in that direction, right? And so now you can start to see the tie-in to trigonometry, all right? We're basically there. So I'm going to get ready to talk about our first notation, break this down in more detail. But in this video, all I wanted to do is share with you what a vector represents, all right? So oftentimes some things just need magnitude, right? Like just how fast I'm going or how much money I owe you. But a lot of times in science and math, we not only need to know my magnitude, right? But I also need to know my direction. And as soon as I start doing that and I orientate myself, what we have is basically a vector, all right? So that basically serves as your introduction. Obviously, I have to build on this and start talking about notation and other things with vectors. But obviously, those are in some videos coming soon. All right, so I will talk to you in a moment.